All right, the recorder is started. The audio is good. The video is good. All right. Okay. All right. It is 9 o'clock. You're the only person in the room, so no one else can actually ask questions, unfortunately, except for you. Um, all right. So this is question number one from the final exam from last semester. The final exam is 2 hours long, so we have until I have put that into the calendar already. So for anyone who is watching this, um, if you go to the calendar of this class over here, it is on the 15th, which is next Monday. I'm just waiting for the calendar to load, and I believe it is from 8 a.m. Okay, so there we go. So this is our final exam for this class. It is 8 a.m. to 10 a.m. on next Monday, which is the 15th of December. Okay, so that part is done. And now we move on to question number one. Or before we go to question number one, we can just briefly go over some of the points, the instructions of the exam. It's about the same as exam one and exam two, other than the duration. It's about the same. It is an individual exam. I don't want to see people collaborating during the exam. Uh, paper pa- Paper-based content that was prepared prior to the exam can be used. There's no limitation. If people want to bring in entire textbooks or um, a bound version of all the lecture material, that's fine. Okay, as long as it is on paper, it is okay. Basically, this part is essentially the same as the previous two exams, but I still encourage people to read the instructions before your own exam because I have not decided on what your exam is going to look like. Okay, this is from last semester, and I make no guarantee whatsoever with what is going to be on your exam, other than it is going to be on all the topics after the second exam all the way until last week. So you guys will have structures in it, okay, even though this one does not have structures. All right, so this is question number one. I think all three questions are about the same in terms of format. You are given the trace, and you have to reverse engineer the actual code that is consistent with the trace. Okay, so sometimes you can have more than one version of code that can be consistent with the trace, and other times maybe there's only one version. But the key is being consistent. All right. So this is the given trace, okay? And we'll go ahead and look at the potential answers. Okay, so let me start up my editor and put it on the side. So this way we can look at both the trace and the code at the same time. Do we have any questions at this point about the nature of the question? No question? All right, so what I'll do is I'm gonna start up my mouse pad, which is what you guys call the notepad in Windows, and we are going to start a new document, and I'm going to put it on the side over here. And I intentionally put on the line numbers, turn on the line numbers in the code, just so that we can have, we can correspond the line numbers with, um, all the other code, in the program. All right, so we have line one. So remember this part here is these are not the line numbers, these are the row numbers, and these are the column designators. So it's just like a spreadsheet. I use exactly the same format. All right, so we have int main on the first line, okay? Because we have the three variables allocated on line one, between line one and line five. So you can put everything on the same line if you want, or you can basically go like, okay, we have int x, int y, and then int z. And then on line five, we have the first line that actually does something. Okay, so you can put them all on the same line, but putting the variable declaration on different lines are fine too. Do we have any questions about lines 2, 3, 4 being compacted into one single row, which is row 4 in the trace? No questions? Okay. All right. All right. So on line 5, okay, so we look at the trace. On line 5, x got changed to a 3, and we don't get back to line 3 anymore later on in the trace. So that means that line 5 can be as simple as x equals to 3. Okay, so that accounts for line 5. Your x got updated to a 3, and then we move on to line 6. And you can also see that line 6 does not get repeated, which also means it is a one-time assignment statement. So we can just pick the easiest possible way and just say that y equals to 1. And the same thing for line 7, z equals to 1 as well. All right, so up to this point, do we have any questions about how we look at the trace on the left-hand side, and then we essentially reverse engineer the whole thing back into the original code? We get, okay, all right. But starting on line 8, we have to be careful, okay? Because when you look at line 8, there are two things that gave away what kind of a statement it is. One, the comments column is no longer empty. Two, it happened multiple times. On line 8, appeared multiple times in the trace. So what does that tell you? It's a loop, and what kind of a loop is it? What kind of a loop would ask the questions first and then do the stuff that is actually repetitive later? So we have two kinds of loop. One is a do while loop, one is a while loop. So which one would that be? The while loop, exactly. This is a pre-checking loop because we can see that the repetition or the other lines that also got repeated would be lines, 10, 9, 10, 11, 9, 10, 11, and so on. And we can also see that when we are ending, we jumped all the way from line 8 to line 13. Okay, so that means we can also just kind of pre-fill everything up to line 13, and we are fairly sure that this is where we see the return 0, and then we have the end of main. Because the last line that was recorded here was line 13. All right, so now we have to figure out what is line 8. As you guys already identified, it is a while statement, and it is while x is greater than 0. So now we have a suspicion that we have curly braces around here. Okay, so we're gonna have to check later on whether that is the case or not. Fairly sure that is the case because we have lines 9, 10, 11 to fill in these three lines over here. All right, so now we look at the pattern and we ask what is on line 9. The first time we got to line 9, y got a value of 2. The second time, y got a value of 4. And then the third time, y got a value of 8. So we know that y is the one being affected. We just don't know what the expression may look like. So now it is a question of, do you recognize a pattern? Y was initialized to 1, and then it became 2, and then from 2 it became 4, and then from 4 it became 8. So the question is, what can make that happen? It's multiplied by 2, or you can say y gets y plus y. Both are acceptable answers. Okay, so let me just write it out here. Yeah, y plus y. Yeah, because y plus y is the same as 2 times y. So you can either do this or you can say that. Okay, so either one is fine. In other words, I'm not looking for a very specific answer. I just need your code to be consistent with the trace. Are we good so far? Okay. Now, there's a really, really long way with a very obscure expression that can also give you the same thing, but I'm not going to talk about it unless you guys are really interested about that one. A little bit? Okay. Okay, so I can give you the answer to that one. So this one is basically saying if x equals to 0, then we have 1. Otherwise, if x equals to 1, then we have 2. Otherwise, when x equals to 2, uh, question mark, we get 4. Otherwise, if x equals to 3, yeah, you get the pattern, right? Yeah, I don't think anyone is going to go for this one, even though it is technically correct. But I think most people just go like, oh, that's the easiest answer. Okay? All right, so what about line 10? So we have to look at the side effects of line 10 and then try to kind of go backwards to figure out what it is doing. So you can see how line 7, we initialize z to be a 1, then became 3, then became 6, and then it became 6 again, and then that's the end of the last update. All right, so what do you think happened to z, local variable z? Hmm. Okay, so y starts with a value of 1, and then z starts with the value of 1, too. So no matter what it is, we know it has to do with z, right? And so you look at how it is changed. So 1 to 3, it is adding a 2, but 3 to 6 is not adding a 4. Okay, so let's just say that we say that we don't know what it is for now. Okay, we will go back and try to look this up. So in an exam, this is exactly what you should do. Okay, if you're kind of stuck with one thing, but you go like, oh, maybe I can work on the next one because the next one seems pretty easy. Move on. Okay, make a little note on your answer that this is something that you might want to go back and backfill, because I give you partial credit for everything that you figure out. Well, I shouldn't say everything, but for most of the significant stuff that you figure out, I give you partial credit. So don't waste your time on one particular thing for too long, and then just move on. Okay, time yourself so that you have time to go back and finish up what you left out the first time. Okay, so the last one, which is line 11, we can see how x was initialized to 3, and then after line 11 it became 2, after line 11 it became 1, after line 11 it became 0, and then we exit the loop. So what is the easiest way to specify this? X gets x minus 1. Okay, it's x gets x minus 1. Okay, very good. So I think that explains the line 11 fairly well. So now we have time to go back to z. In other words, you first take a look at the number of questions. Okay, I think there are only 3 in this case, and you have 2 hours. So 2 hours would add up to 120 minutes, which means you technically have like 40 minutes on each question. Okay, so now that I look at the clock and go like, oh, I only used up maybe about 15 minutes. I have some time, so I'm gonna spend the time to go back and look at line, um, what was it? Changing the y, that would be line 9. No, line 10. Okay, it's the z. Okay, so we go back to look at line 10 and go like, okay, what can possibly explain the way that z gets its value changed? All right, so we have to look at all the combinations. Okay, so if I add this 6 to, hmm, I created a puzzle that I find challenging to fix. Usually I can figure this out like really quickly, but I'm gonna take a look at this one. Okay, so let's let me go through the thinking process. Okay, so we know that it is going to have something to do with one or two of all 3 of the variables. So it can involve x, y, or z. X is decremented afterwards. So 3. hmm, I'm fairly sure that it has nothing to do with y. Okay, go ahead, give it a try. That's very good. All right, so let's see whether that works. Yep, you got it. Yep, very good. Good job. So Z gets Z times X. So let's double check. I think you're correct. So the first time, when we updated to 3, at that time, Z itself was a 1, and then X was a 3 at that time. So 3 times 1 is in fact a 3. The second time, when we get to this multiplication, when we get to this result, Z itself was a 3, X was a 2, 3 times 2 is indeed a 6. And then the third time, when we update, Z had a value of 6, X had a value of 1. 6 times 1 is in fact just 6. So it is consistent with the result. So very good job. Yeah, that's a pretty high IQ kind of maneuver. I just want you to let you know. Yeah, yeah. Yeah, from the IQ test that I have taken, that would put you easily in 120. Yeah, yeah, I think so. You should probably, all the people in this class, including people who are just watching this, it's not, take one that is free, okay? I don't believe in paying for IQ tests, so you can try to take one that is free. Since we are on this topic, you can also just go online, look for the IBM Programmer Aptitude Test. This is what IBM, the company, used to test their employees. So I would search for images, and this is one of the photographs of the test. Oh, that's the key. That is actually just the answer. That is instruction, and let's see. Okay, let's hit some of these. But if you can find it, it's the PDF. Yeah, possibly. Yep, there we go. Find the rule in each series and indicate the choice which completes the series. Yep, so that's it. Yeah, this is pretty good. It's kind of like our exam, except this is actually used by IBM. Let's try one of these, okay? Let's try number 4. 11, 14, 18, 23, 29, 36. What is the next number? This one is fairly obvious. Hmm? Yep. So the difference between these two is a 3, 4, 5, 6, 7. So it'll be 8 between this one and the next one. 36 6 plus 8 would be 44, right? So the answer is C. The key is actually in the same document too. So you can go through this, go through the key, and figure out how you score. This is actually kind of the same thing as an IQ test, okay? Except in IQ tests these days, they don't do math. Instead, they use pictures with different patterns. Like, you have like 4 quadrants, and then you have a circle over here, a filled circle, an empty circle, and stuff like that. They try to look for spatial patterns. This one is definitely a lot more leaning on the math side. But guess what computer science is? It's leaning on the math side. So I think this is a good test. Okay, but I think you're gonna do well in this test too. Yep. So give it a shot. Yep. All right. So this is I'll leave it up. All right. So we got the first one solved. Now we move on to the second one. This is the second one, which is a little bit more involved because it involves the use of an array. So what I'll do is I am going to open up the document in its own window so I can move it around. Let's see, move on. I want to control how I open it. Okay, so we'll open it like that, and then the document viewer, or we can use mm, I guess document viewer would do. That we do. Okay. The reason why I want to open it on the side is because I need some room on the right hand side or the left in order to fit in the actual code. Okay, so there we go. And now we go back here. All right, so now we open a new document. This is for this particular question. All right. Hmm. So what do we do here? Well, we can see that the first line is line one again. So that means the main function is on line one. So int main like that. That's line one. And then line six is the first line that actually does anything useful. So now we have all these four lines to specify the variables. So in this case, we have an integer array. So A is an array with 5 elements. So we have int A, square bracket, close bracket. And the only way to assign values to begin with, because you can see the elements of array A did not start with question marks. So that means they come initialized. So the only way to come initialized is to use this particular format. So this is a format that we have used in one of the homework assignments, or at least one of the homework assignments, is basically to start with an array that has initialized values. And then we have three more variables, I, m, and n. So that will use up the next three lines. One is int I, one is int m, and the other one is int n. There we go. Now, whether you followed exactly the same order is not important. Okay, so you can switch the orders around a little bit. It doesn't really matter. So now we move on to line six. So line six is an easy one because you can see that line six did not happen again in the future. So that means it is a standalone statement that only executes once. And the end result is m ends up with a value of 5. So the easiest way to do that is simply to say m equals to 5. Now, if for people who want to say, oh, but I want to pick out the first element of A because that's also a 5, that's okay too. Okay, so that means we just need it to be consistent. It doesn't have to be exactly the same as what I had in mind. Question? No. Okay. All right. So I'm just going to pick the easiest possible answer, which is really just a 5. Okay. And then we move on to the next one. I gets 1, and then we have n gets 5 again on line 8. So now we move on to line 9. Line 9 gets a little bit complicated because line 9 is repetitive. We have line 9 over here, over here, over here, over here, and then finally over here. And the last one is the one that is significant because we can see how we jumped from line 9 to 15 and then a post. So that means we have the same kind of scenario as the previous one, where line 9 is a while statement with a condition. The condition is easy to find out because it is always spelled out in the comments column. So that means that in this case, it is just I is less than n. All right. We also know where the end of the loop is. The very last line that does anything useful in a repetitive fashion is line 13. So that means that the actual meaningful part is up to line 13, which makes line 14 very likely to be a close brace, so that line 15 becomes the return 0. And then after the return 0, we also have a close brace to close the beginning of the function definition. So now we go to line 10, and then we ask, what can line 10 be doing? So line 10 is a little bit interesting because it is also having a entry in the comments section with no variables updated. Okay, so now you have to ask yourself, do we have another loop, or what is the only other kind of statement where you can have a condition to start with in that statement? We only have three different kinds of statements that can involve conditions: a while loop, a do while loop, and also a Mm, yes, we have compare, but there are three control structures or statements. So we have a while loop, a do while loop, and no, conditional, an if statement, right? So, okay, so now you have to ask, is it another while loop or is it a condition? So the way you can tell that is to see whether there's a micro repetition within between line 10 to line 13. Do we see micro repetition? There's no micro repetition here before we get back to line 9. No micro repetition, no micro repetition, no micro repetition. Yeah, we basically have a mini loop inside here. So if you see line 10, line 11 back to line 9, then we have an embedded loop. We do not have an embedded loop here. So now you have to look at the differences. Sometimes after line 10, we follow immediately by line 11, and then we get to line 13. And other times, we go from line 10 to line 13 immediately. So that's the difference, right? Okay, let me point out one more time. We go from line 10 to line 11. We go from line 10 to line 13. We go from line 10 to line 11. We go from line 10 to line 13. So what is that pointing to? Conditional statement. The conditional statement would be the easiest to explain that. So we kind of plug in the conditional statement first to see whether it makes sense. If it does not make sense, then we come back and fix it. But I think this is going to be it. So the condition of the conditional statement is always spelled out already in the comments, right? So we know that line 10 is going to be asking, is a bracket I less than m? That's the statement. And we also know that line 11 is the only one in the condition. We don't see line 12 anywhere within here, which means line 12 is very likely just the close bracelet. Okay, so now assuming this is the case, what does line 11 do? So we look at the first time we get to line 11, m becomes, from 5, it became a 1, and then on line 11, it goes from a 1 back into a 0. So we know that it is changing m, so we know it is m equals to something. The question is, what is that something? It starts with a 5, and then it becomes a 1, and then it became a 0. So what do you think that is here? So the other thing you also want to look at is the condition itself. Okay, so when we evaluate the first condition here, like this one, what is the value of I? The value of I is 1 at that point. And what is at a bracket 1? It has a value of 1. All right. The second time we update local variable m, we updated that to a 0. And then you have to ask, what is I at that point? I at that point is a 3. What is a bracket I? It's also a 0. Hmm, okay. So maybe this is just that. Okay, it will be consistent with the code, right? It'll be consistent with the code. And now, what do we do after the loop? What about line 13? Line 13 is pretty easy because every time we get to line 13, it went from a 1 to a 2, and then went from a 2 to a 3, 3 to a 4, 4 to a 5. So what would be the easiest way to express line 13? Yep, and that's it. Okay. So we're understanding the process of doing this. Okay. The anchoring part, I would say, is always looking at the comments column, which is column A. And then the second thing is look for repetition. Okay, because whenever you see a repetition, you know a loop is involved. And if you have a while loop, the condition is evaluated at the beginning or with a line number that is lower. If you have a do while loop, then the evaluation of the condition is at the bottom part. But nonetheless, in either case, you will see a repetition. Okay, so are we good with question number 2? We're good. All right. So here's question number 3. So question number three is okay. Do we have? Oh, we have four questions. I lied. So there are four questions. This is question number three. Okay, that's the trace. And let me go ahead and create a new one over here. Okay, so the way we look at this one is, we know there's a function call of some kind because we can see um, a return column, which is return info. From this semester, it's called the return info cell. So we can see that the return info cell was created over here. It's also created over here. And there are no parameters in either case. And so we can go ahead to start to construct the program. Okay, we know that we start execution on line 10. So that's probably int main, open paren. Line 11 is likely to be the definition of local variable x of main, int x. And then on line 12, we have something like x equals to something. Is that okay so far? Because we can see that on row 6 of the trace over here, on row 6 over here, we can see that the right-hand side of the assignment is replaced by a single question mark, which means we have a function call of some kind, but we don't see any parameters being passed. So that means that we have a call to a function, and there's no way you can actually know the name of the function. So don't try to look for the name of that function. Just make up a name, okay? I'm just going to say func1, okay? But because it has no arguments, because if there were arguments, we would have used up additional columns for the arguments. So that means we just have open and close paren here with no arguments in between. Func1 is defined on line 7 because that's the next line that we go to. So now we go to line 7 and then we say, okay, this is func1. It has no parameters and it is going to end on line 9. Is that okay? So now the question is, what do we do what do we end up doing when we get to line 8? Okay, when line 8 executes, what do we do? Yes. Huh? Yeah. Okay. So we know what line 8 sort of looks like, okay? Because it looks like this when we get to line 8. So when we get to line 8, we have to allocate another column E, and we record that when we get back to line 8, we still have the addition to finish, and we still have a call to Johnny, and whatever we have to do first is a function call as well. And then it is also a return here. Okay, so we know that line 8 is a return, and then we have some kind of a function call plus Johnny, Johnny, open and close paren here. So now the question is, what about this name over here? So we're gonna give it a made up name first, okay? And then later on we'll go like, oh, okay, maybe we don't have to make up a name here. So we're gonna call this func2. This is func1, this is func2. All right, so once that is set up, we get to line 1. So now we go to line 1 over here, and then we go like, okay, that has to be where func2 is located. And it gets to line 2. Oops, okay, it gets to line 2. So line 3 is probably just a close brace over here. And then line 2, when we can see that when we execute line 2, this is the execution of line 2. What did it end up doing? Hmm? It returned a 7. It returned a 7 because what line 2 ends up doing is to copy and paste the rightmost return info column, copy and paste, but it changes the question mark to a 7. Okay, okay, yep, okay. I think on paper it looks a little bit better. It doesn't look like a 7 on paper. Okay, so we can look at func2 and say, okay, it is just returning 7. Okay, or the easiest way to explain it is it returns a 7. Are we doing okay so far? Okay. All right. So Then it goes back to line 8. And then line 8 says, okay, now we have to call Johnny, which reallocates the column E. And this time, Johnny is the one replaced with a question mark. So far, we don't have any additional information. But when Johnny is called, we end up on line 4. So that means Johnny is on line 4. This is where Johnny is. Does that make sense? Okay, because when you execute the call, we continue execution on the line 4. That's where the called function starts. All right, and this is probably a close brace over here. So now we ask, what does line 5 do? This is the execution of line 5. What does it end up doing? It copy and paste the return info cell, change the question mark to a value of 5. Exactly. So this returns a value of 5. And then when the 5 is returned, we get back to line 8. Line 8 is now saying, okay, because func2 returns a 7, that's what this 7 is coming from, or I should say point here. That's what this 7 is coming from. And then Johnny returns a 5, and that's what this 5 is coming from. Then we evaluate it to x gets a value of 12, and that means this is all done over here. So by the time we get to line 13, it is the return 0 to end the main function, and then we have a close brace. Are we still doing okay so far with understanding how to track things down and understand how to backfill the program as a whole? Okay, so everything still has to do with the convention that we use when we work on the trace. Instead of a return, yours is going to be return info, okay, which is, I changed the name a little bit between the semesters, but it's going to be the same thing. It's just labeled differently. Are we still doing okay so far with question number 3? Do we have any questions about number 3? No questions? All right. So now we move on to the last question, which is question number 4. All right. So here's question number 4, which is a little bit even bigger. Okay, it is a even wider trace. So that makes it a little bit harder for me to track it on using the computer. So I'm gonna have to flip-flop between the two screens. Okay, so this is gonna look a little bit disorienting because I have to kind of switch between the screens. So let's do this. Okay. So start another document, like so. And I would just kind of backfill, like up to the last line over here. So it has up to line 19, I think, at least. Okay. Probably a line 20 at the very end. Yep. So up to line 20. And now we go back to the code here and backfill it. The fact that we are starting on line 14 means main is on line 14 because that's the entry point of the entire program. So we have int main over here, and line 21 is likely to be the close brace corresponding to the open brace on line 14 because the last line that we actually execute is on line 20, kind of way below that. All right, so now we go to line 15 and ask what does line 15, or in between line 15 and line 17, what do we end up doing? We have an array A that is initialized with the values of 614. So this one is the same as before. We have an array definition. It is already initialized, so that means we have to use this format. So we have 614 initialized in the array. And then on line 16, we can say n is defined. So we have int n over here. And then on line 17, we can have x also defined over here. And you can see how n starts with a question mark, x also start with a question mark, which means they're just usual definitions. They do not come initialized. Are we good so far? Okay. So now we move on to line 18. Line 18 is over here. So line 18 just wants n to have a value of 3. So I think the easiest way is to say that. Okay. But if you remember the fancy way to doing the same thing, you can also use the fancy way, which is size of a divided by size of a bracket 0. So that would work as well. Okay, but I think most people do not remember the fancy way to do things. So just a simple three would also do the trick. Okay, because what I'm looking for to deduct points would be things that are either missing or inconsistent with the trace. So if you were to use the size of solution, it's fine. It is consistent with the code. If you are to use just three, it is also correct, okay, because it does not conflict with the trace itself. Okay, so now we move on to line 19. So line 19 is doing something that's a little bit more interesting. It is calling a function. Now, how do we know it's calling a function? Because we see additional columns allocated, and one of the new columns allocated is labeled return, or in this class, we call it return info. So every time you see a return info, especially when the return line number or the line number that's returning to is the same as the line that we are on, that gives you an idea of what the line actually looks like. It is x equals to some kind of function call. Okay, because the function call is the portion that got replaced by a single question mark. So that means I can now say that, okay, on line 19, it looks like x equals to some kind of function call. Once again, I'm just going to call it func1, but this time it has parameters. It has a parameter b, it has a parameter I, it has a parameter n. So that means I have three things to fill in between the parentheses. Are we good? Okay. So every time you have arguments, okay, on line 19, those things that we have to backfill between the parentheses, they're called arguments because this is looking at things from the perspective of the caller. So from that perspective, we look at column I, and column I is allocated for parameter I, but has its own value, which means this one is passed by value. If it is passed by value and it has a value of 0, and it's only used once, might as well just specify 0 here. And same thing for the 3. The first one is a little bit tricky. It is a reference to column C. So when you look at column C, it is the beginning of array A. So we are passing something by reference, and it is referencing column C. So at this point, there are two possibilities, okay? Because you can be passing the entire array A like that, or you can pass in element 0 of array A by reference. So we cannot differentiate the two cases right now, okay? So you have to kind of leave a note to yourself and go like, could be A bracket 0 instead of A. So later on, we'll come back and resolve that, okay, to see which one it really is. Because right now, I cannot resolve it. Okay, so this is important. Okay, are we understanding why there are two possibilities for the first argument, whether it is just an integer that is passed by reference or whether we're passing the entire array? Because in both cases, what the function gets is a reference to the first element of the array. hmm It it depends on whether it's passed by reference. So give me a second here. Yes. So right, so I can also explain from the perspective of the callee or the function being called. So on line one, because we know the function is defined on line one, because that's where we went. So now we also know that line one is a function that returns an integer, because otherwise we cannot make the return value being stored in variable x, which is an integer. So that what we know. This is func one, and we also know that it has three parameters. So we go like, okay, these are the three, and then we have an open brace over here. Now with the middle one, it's pretty easy. It is just, it has a name of I, and it has the easiest way is to think that it has a type of integer. So that's int I. Okay, and the last one has a name of n. So we just say int n. It is definitely passed by value because otherwise this would not be it would not be a concrete integer. It will be a reference to some column. So the first one is the one that we don't know, okay, because the first one could be something like this. B can be passed by reference like that. Now, if B is passed by reference like that, then this will have to be A bracket 0. In other words, we're passing element 0 of A on in main by reference to parameter B of func1. That would be consistent up to this point, okay? But later on, okay, so I'm going to have to switch between the screens here. So you can see how this one is still referring to column C, and this one is still referring to column C. So at this point, it is consistent, but um, let me see. When we get to the other points here, um, all right, so we're gonna go with this assumption, okay? Because later I can just show you why it doesn't work later on, and then we'll come back and fix it. Okay, so this is a possibility. So we can say that B can also be an array. So we just leave a question mark open here. And then we get to line 3. And all right. So line 1 also says we have a local variable m. So m is a local variable of func1. That's where we put that. Are we good so far? Because we can see m is allocated on line 1 or somewhere between line 1 and line 3. Okay. On line 3, what is being done? So line 3 evaluates a condition of whether I equals to n minus 1. So once again, we have a question of, is this a loop or is it a conditional statement? Okay. So how can you tell whether it is a loop or a conditional statement? Exactly. Okay, very good. Okay, so we can see the first time we went from line 3 to line 6 when the condition is false. The second time, same thing, when from line 3 to line 6 when the condition is false. And this time when it is true, we go from line 3 to line 4. But a while loop can do this too, right? Because if the condition of a while loop is false, you just skip over the entire loop. You go to whatever statement is next to it. When the condition of a while loop is true, you just go into the loop and perform whatever is in the body. So how can you differentiate between a loop versus a conditional statement? It is at the end, what do we do? In a conditional statement, at the end, we just kind of fall through to whatever is after the conditional statement because it's a one shot. With a loop, at the very end of a while loop, go ahead. You go back to the beginning. Very good. So do we see we go from line 4 back to line 3? No. So that means it is not a loop. Instead, it is a conditional statement. That is correct. Okay. So now we go to line 3. We say, okay, we know this is a conditional statement. The condition itself is not the difficult part, okay, because it is spelled out in the comments column. Okay. So now we have open brace here. Line 5 is never appearing in the trace, so that means it is likely to be just a closed brace. Are we good? Okay. And then on line 4 over here, okay, which is, this is one of the few times when line 4 actually executes. So we want to understand what is on line 4 in order to kind of figure out, what possibly can be, what line 4 can be. So when we look at the result of line 4, it is closing the entire thing. And more importantly, I think I'm missing a column here. There's a there's a return info cell following this. All right. And in the exam itself, I actually told people about what that is supposed to look like. Um, let's say I do not, okay? The question is, can you figure out what that return info cell looks like? In other words, can we deduce what line 4 did? It returned a value of 4. it returned a value of 4. Um, so now the question is, where is that 4 coming from? Okay, so if you want to figure out where that 4 is coming from, then you have to look at other things, like, do we have a 4 or anything close to a 4 in terms of the parameters? Yeah, we have a 2, we have a 3. This one is always a 3 anyway, by the way. And we have a 2 over here. But then you also look at this and go like, oh, there's a 4 over here. So how do we get to this 4? This is element 2 of array A, and I is 2 at this point. So that means line 4 can be return B bracket 2. Not A, but B. Okay, so let me explain why it is not A. Because A is a local variable of main, which means you can only see the name A when you're somewhere between line 15 and line 20. That makes it a local variable. So that means the name A is not visible when we are on line 4. So how do we get to array A on line 4? The only way to get to it is when B is not passed by reference, but instead it is an array. Because if you pass by reference like this, then B is not considered an array. If B is not considered an array, you cannot use the indexing operator. The fact that we are relying on the indexing operator basically says it is an array. You have to pass an array to a function in order to use the array. Okay, so now we can go back here and say, okay, B is not an integer passed by reference, but instead it is an array. Because in C++, the only way you can pass an array is to pass it by reference. Is that okay? So that also answers the question over here, because we now know that A is an entire array being passed as an argument. So now we go back and fix these two. Is that okay? So there can be points where you go like, I cannot tell whether it's one way or the other, and then you resolve it later on. Okay. All right. So now that we resolve what is line 4, even though it kind of have a column cut off, with the column not cut off, it's actually really easy to figure it out because it'll be kind of spelling up pretty clearly. So what about line 6? What does line 6 do in the trace? Okay, so now we switch back to here and we look at line 6 over here. And you can see that on line 6, we call again. On line 6, we call again. And then when we get back to line 6, it is m equals to 4. So you can also see from the return info cell over here that line 6 looks like that. Okay, it is an assignment statement. M is on the left-hand side, and the function call is to the right-hand side. Are we good so far? Okay, so that means if I go back to this trace over here and go to line 6, it is basically saying m equals to func1. Okay, we know it's func1. How do we know it's func1? Because the next line that executes after we set up the column is going back to line 1. So it's a function calling itself. All right, so it's func1, and every time you call func1, you have to supply the 3 items. Okay, so now we have to figure out what these 3 items are. And the way we can figure that out is we can see that I goes from 0 to 1, from 1 to 2. Okay, I think the best way to describe it is just I plus 1. But it's not I gets I plus 1, it's just I plus 1 over here. Okay, and what about n? If you look at n, it is a 3 here, it is a 3 here, and it is also a 3 over here. Yeah, looks like we're just passing n along unmodified. So n is really just n itself. What about b as a parameter? So when you look at b as a parameter, they're all the same. In other words, we're just passing b along, as it is. This is just B. Are we good so far? Okay. So I'm basically looking for a pattern. Okay. I'm looking for a pattern of every time we get to line 6, what is changed across the arguments. Well, the first one doesn't change, so I can just pass along what I got, right? N doesn't change, so I just pass along what I got. The middle one, or the second argument, is the one that is changing. It started with a 0, then becomes a 1, then becomes a 2. So that means the easiest way to account for that 0, 1, 2 sequence is to say whatever I got, I just add 1 to it, pass it along. Are we doing okay so far? Okay. So now we can see that there's no line 7. See, there's no line 7. Oh, there's a line 7 over here. So line 7 is over there, and line 6 is over here. And there's line 7 after every line 6. See, you see that there's a line 7 after line 6. There's a line 7 after line 6. And this is the call. Okay, so that means we do have a line 7 doing something. So now the question is, what is line 7 doing? So we look at the trace, okay, and we can see that line 7 does not change anything on this side. So it's not an assignment statement. If it was an assignment statement, we would have seen something change over here. But we can also see in the comments column that it is evaluating a condition. Yep, is that correct? Okay, so now we have that whole question again. Are we dealing with a while loop, or are we dealing with a conditional statement? So the question is, you answer the question by asking what is right after line 7. So on row 24 of the trace, we can see that right after line 7, let me use the mouse pointer here, we get to line 8. But the next time we get to line 10, but when the time that they go to line 8, it did not go back to line 7. So that rules out this is a while loop, which means it has to be a con conditional statement. That is correct. Okay, so we now know that line 7 is a conditional statement. Okay, so we go back here. It is a conditional statement. The condition, once again, is the easy part because it just cut a copy from the comments column. So now the question is, what do we do on line 8? Okay, line 9 is never really does not appear in the trace because the next line is line 10. So that means we don't really have to worry about this line 9. The question is, what is on line 8? So now we have to look at the only time line 8 executes, and we see what it's doing. So on line 8, it is changing a return info cell. So if it changes the return info cell, okay, let me do it one more time. This is the execution of line 8. What is the side effect? It doesn't change a local variable. Instead, it looks up the return info cell and change the question mark to a particular value. So that means it is a return statement of some kind. Okay? So every time you figure out a clue, you just put it here, even though you don't quite know what it is returning yet. Okay? So now we try to figure out what is it actually returning. So when we get to this line 8, which is the only time we get to line 8, is it returns a value of 1. So now the question is, where is this 1 coming from? And well, the easiest solution is to say it's returning the value of I, right? So you can basically go like, okay, maybe it's just I. But since this is the only time that we get to line 8, even if you say return 1, I cannot say that you're wrong because that's the only clue we got, right? But I think it makes more sense that it returns an I, but you know, it's okay if you just say 1. Okay. All right, so we have the puzzle pretty much all figured out because line 10 actually does not really do anything. When you look at line 10, oh, it does do something. Oh, so line 10 does do something, and what it does is it returns a value of 1 in this case, because you can see how the question mark is changed to a 1 in this particular case. So now the question is, where is that 1 coming from? And this is after line 7. So after line 7, we get to line 10. So that's probably an else over here. Okay, so else return something. We don't know what that is for now. Close that. And likely that we have another close over here because we don't see the execution of line 12 either. So that's probably just a close curly brace. So the mystery now is, where is this 1 coming from? And we can see that there's no particular. Okay, so if you just want to say, but this is the only time we get to line 10 and it returns a value of 1, if you just put a 1 here, I cannot mark you wrong either. Okay, so that pretty much fills in the entire program. And line 20 is just a return 0 because by the time we get to line 20, we deallocate everything and then we get to post. Mm-hmm. Yeah, sure. Well, that will work, but that usually it is depending on some of the values. And line 8 is doing the same thing too. Don't forget line 8. Because when we execute line 8, which is here, it is also returning a value of 1. It changed the question mark to a 1. When we execute line 10, it is also changing the 0 to a 1. This 0 got turned into a 1. Yep. So you can say this is just 1. You can say this is returning b bracket 1, but I think it's probably more like this is returning b bracket I. This is returning b um, new. Okay, I take it back. Okay, the recursive call is on line 6. Okay, and line 8 is just returning. Okay, that's the function call. If b is less than m, b bracket I is less than m. So this one can be I, and then this one, this can also be m. Okay, let's check it. Okay, let's check whether line 10 can be m also. So when we get to line 10, okay, when we execute line 10 over here, it returns a value of 1. Okay, but the question is, what is the value of m at that point? It is also 1. Yep. So you have choices over here, but from the logic of the program, it is more reasonable that it's returning m. Yep. Okay, going forward. Yeah, so going forward, the first time we call the function is on line 19. So on line 19, when we specify the entire array, which is A, and parameter B is also an array because of the square brackets, that tells you that we're trying to pass an array from the column main to func1. Yeah, it is array B. So B as a parameter is a reference to the first column of the original array, which is array A of main. Yep. Because in C++, the only way you can pass an array is by reference. So and the only thing you pass in that case is a reference to the first column of the entire array. So that's why you're not passing columns C to E, you're passing only column C, a reference to column C, because in C++ you can only indicate what is the first column corresponding to the array, but you cannot tell how big the array is, and that's why we need parameter n on line 1 for func1. That's what n is for. N tells the function that is being called how many items do we actually have in the array. All right. So given that is the whole program, okay, the question is, what does it do? Okay, this is the actual code, okay, but you can also use just return 1 on line 8 and line 10 and use return 4 on line 4. I cannot mark you wrong because it will still be consistent with the trace. But this is the actual intention, the actual original code. So the question is, what does it do? So the way we figure out what it actually does is to ask, okay, what does it mean when I equals to n minus 1? When I equals to n minus 1, I is the last possible item in the entire array because we come from 0. So when we at the very end and there are no more elements, we just go like, I'll just return the value of the last element. Okay, so that's one clue. Okay, by itself is inconclusive of what func1 actually does. The real clue of what um, func actually does is we do the recursive call here, okay? But when we perform the recursive call, oh, actually, I missed one more thing too. Uh, line 6 and there's a line 7. Mm, definitely missing something here. There's no line 5. So there's a line 7. Ooh, okay, I know what. Okay, I'm missing something kind of important. Okay, if the okay, I'm missing the else here, and I'm just looking at the line numbers, where the braces can be. Okay, so that means there's nothing here. There's no line 9. After line 8, it just returns. Line 8 is the actual return. So line 8 is the actual return. There's no line 9. Okay, I think I see. Okay, I see. Okay, so the nesting is actually more like this. Now, what I had before, you can get full credit already. Okay, that is the correct solution. But this is the actual original code. The original code is more like this. Um, then we have one extra close brace. This one should not be here. And then there should be else over here. That is the original code. Okay, let me fix the indentations. Now, if you come up with the solution that we had earlier, that would count as a 100% already because your code is actually consistent with uh, the trace. But this is the actual original code. Okay, let me explain again. This is the case when we do not do any recursive call, is when I equals to n minus 1. So we just return the last element. Whatever the last element is, we just return its value. If we have additional elements, then it will call this function, okay? And then what it will do is it will compare whatever func1 returns to b bracket I. And if b bracket I is the smaller one, it returns b bracket 1. On the other hand, if m is not greater than b bracket I, it returns m instead. So that means it returns the smaller of the two. So that means your func1 is finding the minimum of the entire array. Yep. It's finding the value of the minimum element of the entire array. So that means x should end up as 1 because element 1, which also has a value of 1, is the value of the smallest element, and that's exactly what it did on line 31. Yep. But there are multiple possible solutions just because we cannot resolve. We did not execute these return statements multiple times. So that means you don't need to come up with this particular solution. The one that I had before is already sufficient. Mhm. So the bottom line is consistency. Is is the code that you give me consistent with the trace? If it is consistent, I cannot give you anything less than the full mark, 100%. All right. Yes. So I give you enough room with line numbers. So this way it's easier for you to just go like, okay, this is line one, this is line two. So you don't have to give yourself line numbers. You can just rely on these line numbers. Yep. All right, that's pretty much the exam from last semester. Do we have any questions about this? Yeah, you have to. So the most important part to review and also prepare your notes for the exam is what do we do for each kind of parameters? That's one. Two, you have to understand arrays. Three, you have to understand structures because structures is something new. So this test did not have anything about structures because I ran out of time last semester. We never got to structures. Yep. Yep. hmm And then the four questions are also staged. You can see how the first question is a lot easier to answer. The second one is a little bit more challenging. The third one is okay, that's a little bit more. And then the last one is the one that is kind of like, oh, that's crazy difficult. So, I intentionally try to make the exam questions so that they vary in difficulty. So the first thing you might want to do is to scan all the questions and pick out whichever one is the easiest one to work with because they all carry equal weight by intention. So even the easiest one has the same weight as the most difficult one. That makes it easy for you to make a decision, right? It's like this one is so easy, I can get it done in 10 minutes. That one, I'm not sure I can get it done within a half an hour. Get the easy one first. It's worth the same amount of points. But you do need to spend the time to quickly evaluate whether it's an easy one or a difficult one. If it's an easy one, pick that up and just do it first. Okay. So do we have any questions about the exam? Nope. Okay. One more. I know I'm nagging at this point, but set up your alarm clock because the exam starts at 8, not 9. Okay, so even if you have been attending the optional lecture, consistently, like all three of you, the lecture starts at 9 o'clock, but the exam starts at 8 a.m. So make sure you wake up in time to get here. I would say no later than maybe 7:50. Okay, so you give yourself a little bit of time to settle down, okay, and not be in the mood of, oh man, that car cut me off when I'm driving here. I'm so pissed. It is next Monday. It's Monday. Yeah, next Monday on the 15th. Yep. Today is the 8th, so yeah, that will make it the 15th, the Monday. Yep. All right. Well, I don't have anything else to add unless you guys have questions. Okay. You're good? All right. So is that notebook working well for you? Yeah.